Hey everyone, and welcome to this week's episode of BSD Synergy. This week's episode is entitled Into the DragonFlyBSD's Lair. I'm your host Mason Egger, and let's just get on into it. First thing I want to do is welcome all my new subscribers. Last week I had asked if we could try to get over 100 subscribers, and we got there. And now I have a custom URL channel. If you go to youtube.com/BSDSynergy, it'll bring you right to this channel. And isn't that just nifty? So without dillying or dallying, let's go ahead and jump on into DragonFlyBSD. So DragonFlyBSD is a fork of FreeBSD from 2003. Their original goal was to offer native clustering support in the kernel. This typically requires a sophisticated cache management framework for file system namespaces, file systems, and VM spaces. So from my understanding, DragonFlyBSD really is a specialty BSD. After looking around and poking around with it, this is definitely the kind of thing that I would use when I would be doing, like, if I was doing research at an academic level, or I really cared about high performance clusters or performance issues. DragonFlyBSD claims to be the best BSD for performance. A lot of work in DragonFlyBSD has been done on the kernel and the kernel subsystems. There's scheduler abstraction into executable and user thread scheduling. There's a kernel memory allocator, which was abstracted into pieces. Kmalloc is based on an enhanced per CPU slab allocator and is essentially lockless, which I think is pretty cool. There is even an object-oriented memory allocator in the kernel called OBJ cache, which is designed for high-volume object allocations and deallocations. Now, there are a lot of really interesting features inside of DragonFlyBSD, and I'm only going to cover a couple and the ones that really caught my eye. I definitely recommend that you go and check out this BSD because honestly, before I started doing this episode, I had never even looked at it, and I spent quite a bit of time sitting there and reading it going, wow, this is some really cool stuff. So one of the things they have is DevFS, which is the Dragonfly device file system. Biggest feature is the integration with block device serial numbers. This allows DragonFlyBSD systems to reference disk drives by serial number instead of by their base device name. This makes migration between physical ports trivial, and driver changes become transparent to the system, which is really cool. They also have virtual kernels, which honestly I haven't looked up the difference between a virtual kernel and a rump kernel yet, but they really do remind me of the same. I think their purposes are different, but they basically are kernels that run inside of userland. However, the vkernels in DragonFlyBSD, their primary purpose was to make kernel development easier. They also have NFS version 3 RPC asynchronization. They sport a revamped NFS version 3 implementation which gets rid of NFS IOD threads and implements a fully asynchronous RPC mechanism using only 2 kernel threads. The new abstraction fixes numerous stalls in the IO path related to misordered read-ahead requests. One of the things that DragonFlyBSD really focuses on is performance, and they have a lot of performance-enhancing things in the operating system, one of which is the swap cache. Dragonfly allows SSD configured swap to also be used to cache clean file system data and metadata. This feature is carefully managed to maximize the write endurance of the SSD. Swap cache is typically used to reduce or remove seek overheads related to managing file systems with a large number of discrete inodes. Dragonfly's swap subsystem allows support for much larger than normal swap partitions. 32-bit systems support 32 gigs of swap space, while by default, 64-bit systems support up to 512 gigabytes of swap. Another really interesting thing I saw, and I really want to play with this, I don't know much about it, but I read about it and I want to see what it does, are variant symlinks. These are content-sensitive symlinks that give users, administrators, application authors an extremely useful tool to aid in configuration and management. Special var_sim variables can be used with an otherwise conventional symlink, and they are resolved at runtime. They also have DM target crypt, which is transparent disk encryption. This allows a device mapper target called DM target crypt, compatible to Linux's DM crypt, that provides transparent disk encryption. It makes best use of available cryptographic hardware as well as multiprocessor support software crypto. Dragonfly fully supports LUKS crypt setup and TrueCrypt as disk encryption methods. TCPlay is a free BSD licensed 100% compatible TrueCrypt implementation built on the DM target crypt. And last but not least, you really can't mention DragonFlyBSD without mentioning Hammer or the Hammer file system. It's a file system that is written for Dragonfly that provides instant crash recovery, multiple volume file systems, integrity checking, fine-grained history, undo, network mirroring, and historical snapshots. Now, what I find really interesting is that it is immediately available after a crash with no FSCK. I don't necessarily know how that works, but I'm going to look into that, and maybe I'll do a whole episode on Hammer FS. It sounds really cool. The Hammer FX can be 1 exabyte in size. I don't even know where the hell that is in the metric system. And can encompass up to 256 volumes, each of which can be 4 petabytes. That's a lot of storage space. Wow. State of the file system can be accessed live on 30 to 60 second boundaries without having to make explicit snapshots. There's a lot of really cool features in Hammer FS that I was looking at. I was like, I can do a whole episode on this. If you want to check them out now, go ahead and check out dragonflybsd.org/hammer. If not, wait for the future episode when I'm going to cover Hammer FS. Okay, so I'm just going to jump right into installing it and going into the demo. As I learned last week, with NetBSD, I had never messed with NetBSD before, and some of my reactions to how it did stuff might entertain some of y'all. So I've actually not installed DragonFlyBSD yet, and I'm going to go ahead and do a fresh install of it, and we're going to just, kind of record my reaction to it. And, from someone who have now worked on 3 other BSDs, now it's time to see, okay, how does Dragonfly work? So I hope you enjoy this almost quasi-live demo. Setting up the VM now, and Oracle VirtualBox doesn't support it. So if you are going to try this in VirtualBox, I would highly recommend doing it, and you have to pick your operating system at the beginning. Pick FreeBSD. It's probably the closest thing you're going to get in the BSD, since it is a direct fork. Creating a hard disk of 50 gigabytes in size, because if I remember reading correctly, the Hammer file system, while really cool, performs more optimal on file systems that are 50 gigs or larger. So I'm actually making a slightly larger disk for this demo purpose. Okay, and here we go with DragonFlyBSD. A lot of options. Gonna go ahead and go with 1. Probably the best way to go. Nifty that it has all those different modes you can boot into. It sets the hostname to .dot by default in the beginning when it boots. To start the installer, log in as installer. That's definitely different. Okay, interesting. Install DragonFlyBSD. Install DragonFlyBSD. Here we go. Yep. Use return to select disk. Oh, wow. It sees all that. Okay, use the entire disk. Yes, I know. We formatted it. Okay, so you can actually choose the beginning between using Hammer and UFS. So UFS is traditional, but the Hammer is the new BSD file system. And I'm actually going to go with Hammer, because I did that whole big thing about how cool it was. Oh, look, you can choose the mount points. You can choose to encrypt them. You can change that. By default, the swap space is 4 gigs. Wow, nice. Slash is that build is interest. Slash build will hold slash user obg var crash and other elements of the topology that do not need to be backed up. If there's no... Okay, so if you don't want to back up things, you can create a directory for them. Like slash build or slash user object, because they don't need to be backed up whenever you're doing your snapshots. I guess they really are like expecting you to use snapshots on this thing. So, I mean, probably you should configure this properly and set these up so where if you do want to use this as a major backup, you don't back up useless data. But for now, for the purpose of this tutorial, I'm not going to do that. Small Hammer file systems can fill up really quickly, so it doesn't like the 50 at all. It likes having large things. It's fine. So it's interesting to see how quickly it fills up. If it fills up by the end of this tutorial, then we really need to reevaluate. I don't think it will, because I'm really only going to do a couple of installs and just test some stuff. But let's see. Let's see what happens. Okay. You may now wish to install boot blocks on 1 or more disks if you already have done boot manager. Yeah. Okay. We'll just accept this. Yeah. Gotta click on the right thing. There we go. Boot blocks are successfully installed. Hooray! Well, let's configure the system. So let's select our time zone. Okay, so there we go. Date and time. Not too worried about keyboard map. Not worried about root password. Yeah, might as well do one of these. There we go. Add a user. Don't really care. Configuring network interfaces. The hell are these? Yeah, go ahead and use DHCP. Yay. Remove software packages. No. Set screen map. Set console font. Configure host name and domain. I think we're good. Okay. Reboot this computer. Good. Got an IP. There we go. Okay. Root. Yeah, it booted back to the CD because I was root and I didn't have to put in the password. There we go. Okay, so from what I've read, the package manager is installed and rearing to go by default, which takes after its dad, FreeBSD. So if I remember correctly, the command for this one is, I'll just do a pkg info help. Info, not help, vim. No packages matching vim, fantastic. Pkg search editors. Repository Avalon missing. Okay, so let's do that. Hey, thanks, that helps. PKG update. Updating the Avalon repository catalog, which I'm looking at dragonflybsd.org/docs/how-to/how-to deports, and it does say something about configuring it. Now, it did say in here that it should be raring to go on the base system, but didn't look like it was. I guess maybe you just have to do the update to pull the latest, which makes sense. I'm not mad. Still no package named Vim. Okay, so PKG search editors. There's nothing. Okay, so maybe the PKG system isn't here. So according to their site, if you don't see it there, you can do make PKG bootstrap from anywhere. Yeah, didn't know. That's great. Okay, so now it knows. I guess it had to make the connection. Weird. It is weird. It says it's supposed to work it out of box. And I guess it does. I didn't have to go to the internet and get any, like, add repositories like we had to with OpenBSD. Well, NetBSD did work out of box too, as long as you remembered at the beginning to tell it to put the package manager there. It was there. Okay, well, hey, that works. So if you're going to use the package manager, update it first, do some searches, and I don't know. I probably did this wrong, but I don't know. Maybe it just took a while for it to get to the mirror. Oh, I'm dumb. PKG info is obtaining information about installed packages. Read the documentation, which apparently I don't know how to do. There's a lot of stuff to install for Vim. Really? There's 110 packages for Vim. Interesting. Probably installed like the full like X version and everything, and I had to get everything. But it's interesting to see how much is not there. Yeah, GNOME. I see GNOME right there. Okay, so this is with X11 libraries. So I probably, if I would have done a search, and we'll do that in a second. If I do a search on it, I'll probably see like a non-X11 version, which, you know, would have been optimal here. Oh well. NeoVim. There's a next generation Vim? Huh. They just have Vim and Vim Lite. On the other, like on the, I think it was on the NetBSD and the OpenBSD ones, you could see like with X11, without X11. So, okay. So let's go ahead and go into /user. And there are no ports yet. So it says that I should be able to do make dports dash create dash shallow. Huh, it has, looks like it has Git by default. I should have checked to see that. So it's basically, it's checking out the ports tree now, which the Dragonfly ports are pretty much a straight porting of the FreeBSD ports. And I know that they support each other, and they have not diverged so much that they can't bounce things back and forth to each other. So I know that this tree is still relatively close to the FreeBSD tree. Okay, and now we have the ports tree. Into dports, and it looks pretty much the same as your typical ports tree. So let's go ahead and go into editors. You know what? None of these can be installed quickly. Let's go into www, and then wget paste. Interesting. And then you just do your typical make install clean, and there you go. Okay, so that's all I have for this week. I hope you enjoyed this episode and learned a little bit about DragonFlyBSD. I mean, I surely did. Next week, we're going to start getting into actually some of the topic videos, and I haven't really decided which one I want to do yet. There are so many topics in the BSDs, and what I'm going to try to do is I'm going to try to rotate topics that are specific to different BSDs, but I'm going to try not to like do like all FreeBSD or all OpenBSD. I want to give all of the BSDs some love because they all have a really interesting niche. So I'm going to try my best to do like a FreeBSD, OpenBSD, NetBSD, Dragonfly, in that order. Like try to just do a constant cycle where I'm not giving one too much love. I'm going to do some episodes on things that aren't necessarily BSD exclusive. I'm definitely going to do an episode in the future on OpenZFS, which used a lot by FreeBSD, but it's not a FreeBSD exclusive. So I hope you like this video on the introduction to DragonFlyBSD. I know it was a little bit shorter and a little bit less technical than some of my other ones. I have to say that their documentation is superb, even if I can't read it. And their history is really interesting. But if I had, my personal opinion is this BSD, from their documentation and from like their history, their about page, websites, this BSD does not feel like it's a BSD for beginners. It feels like it's a BSD for super geeks, researchers, people that already know exactly what the hell they're doing, and they just want a new, a new venue to try to do it in. So I could be completely wrong, and I'm going to definitely give it a chance, and I'm going to try it because I'm really interested in this Hammer FS thing. It sounds really cool. So I'll probably eventually, when I get to the Dragonfly BSD thing, probably going to do an episode on Hammer FS. So I hope you like this week's episode. I enjoyed doing it. I hope you like the live installation. I did cut some parts out whenever it got slow because I know you don't want to be here watching watching the bar go across the window any more than I do. But if you have any friends that you think would like this channel, ask them to subscribe for me. If you like this video, go ahead and like it. And if you want to leave me a comment, on anything about this episode, about things you would like to see future episodes on, I've got some friends that have commented. I've actually have some people that have actually commented on some other videos that have said, "Hey, I'd like you to do an episode on this," and I've put it away into my backlog, and I'm gonna have to order that up and pull out the next one. But thank you for tuning in this week, everybody, and I'll see you next week.